Hello dear students, welcome back to physics online classes for class 11 students. Let us continue chapter 2 units and measurement. So today we are going to solve some examples on to derive an equation between different physical quantities. This is the second application of dimensional analysis. Remember, in the previous class we solved some examples based on the first application, that is to check the correctness of an equation. Nearly we solved 6 examples based on first application. Today we are going to solve again some examples based on the equations or the relation between different physical quantities. So the first example is to derive the equation F equal to mv square divided by r using dimensional analysis, or the centripetal force acting on a body in uniform circular motion, that is F. F means what? Centripetal force. This centripetal force is acting on a body in uniform circular motion. In uniform circular motion depends on mass of the body. This is depending on mass of the body, speed of the body and radius of circular path. Centripetal force depends on three factors: m, v and r. So derive the required relation for centripetal force using the method of dimensional analysis. So we have to derive this equation using dimensional analysis. In the first application we studied how to correct the equation. This is to derive the equation. Don't get confused with the two application. The first application is related to correctness of the equation. This second application is related to deriving the equation. Remember, this second application is very important for your examination and each problem carries 5 marks. Remember. Now I will explain how to solve or how to derive the given equation. Observe carefully the first example. Similarly, you can try to solve the remaining example. Right? Yes. See here. So I am going to write the equation F equal to mv square r. See here. The given equation is F equal to mv square divided by r. This is the given equation. So this equation I am going to write as, see here, F is proportional to, this is the symbol of proportionality. F is proportional to m raised to a, v raised to b and the third term is r raised to c. How I am going to write the equation? Observe here. F is proportional to m raised to a, v raised to b and r raised to c. Or we can write this equation as, this is the proportionality sign. Instead of proportionality, we can write equal to proportionality constant k. Wherever we are using proportionality sign, this is the sign of proportionality, directly depending on. F is directly depending on mass, velocity and radius. So instead of this proportionality sign, we can write proportionality constant k. What is k here? Proportionality constant. So F equal to k into, remaining is what? M raised to a, v raised to b, r raised to c. This is, let us take it as equation number 1. Is it clear? Where what is k here? Proportionality constant, or we can also call it as dimensionless constant because it is not having any dimension. This is a dimensionless constant. This is the first part. Is it clear? The given equation is F equal to mv square by r, or we can write here F is directly proportional to m raised to a, v raised to b, r raised to c. Or instead of proportionality sign, we can write proportionality constant k. F equal to k into m raised to a, v raised to b, r raised to c. Let us take it as equation number 1. Now, we have to write dimensional formula of equation 1. So, the second point or second step, writing the dimensional formula of equation 1. Writing the dimensional formula of equation 1. Now, what is the equation 1 here? F equal to k, m raised to a, v raised to b, r raised to c. See here how to write the dimensional formula. On LHS side, the term is F. Force. What is the dimensional formula for force? We already know that m raised to 1, l raised to 1, t raised to minus 2. This is dimensional formula for force is equal to, on RHS side, don't bother about k value because k is dimensionless, leave it. Remaining is what? M raised to a. M raised to a means capital M raised to a. Then second term, here I am going to write m raised to a. Second term is velocity. Velocity is given by the equation L by t. This is what? Velocity L by t raised to b. Then third term is radius. Radius is equal to length. So L raised to c. See here how I wrote the equation. I can write here m raised to 1, L raised to 1, t raised to minus 2. This is force is equal to, we can write this equation as m raised to a keep as it is. So L raised to b, L raised to c. So here powers are added when bases are same. L is the same here. So I can write L raised to b plus c, then divided by t raised to b can be written as t raised to minus b when it is taken to numerator. Observe once again, m raised to a, L raised to b into L raised to c. The bases are same, power must be added, L raised to b plus c. Divided by, here it is t raised to b. T raised to b when it is taken to numerator, it becomes t raised to minus b. Let us take it as equation 2. Is it clear? The first step is, we have to write its proportionality constant. F equal to k into m raised to a, v raised to b, r raised to c. Second step, we have to write its dimensional formula. Now we got equation 2. Now, equating the dimensions of m, l, t on both sides. Comparing m, l, t dimensions from LHS and RHS. So, let us compare or equating. What we have to equate? Equating the dimensions of m, l, t. M, l and t on both sides of the equation. Which equation? Equation 2. Both sides of equation 2. So compare all the dimensions from both the sides. So we will get m raised to 1, m raised to a. So therefore we can write a equal to how much? 1. See here, m raised to 1, m raised to a. So I can write a equal to 1. Then second point. Here, b plus c equal to 1. b plus c equal to 1. Let us compare LHS and RHS dimensions. Then, third point. Here it is t raised to minus 2. Here it is t raised to minus b. Minus b equal to minus 2. That means minus will get cancelled. So, b equal to 2. So, what is the value of a? We got a equal to 1, b equal to 2. Then what is the value of c? How to find the value of c? See here. Now we can consider b plus c equal to 1. So c equal to 1 minus b. C equal to 1 minus b value is how much? 2. So c equal to 1 minus 2 gives minus 1. So now we got all the three values. A equal to, see here, a equal to how much? 1. B equal to 2, C equal to minus 1. So these values we got. by comparing LHS and RHS of equation 2. Now, we have to substitute all these A, B, C values in equation number 1. M raised to A, V raised to B, R raised to C. In equation 1, we have to substitute the value of A, B, C. See, I am going to write here. What is the equation 1? F equal to K into M raised to A, V raised to B and R raised to C. This is equation 1. Here we have to substitute A equal to we got 1, B equal to 2, C equal to how much we got? Minus 1. Substitute in equation 1. Substituting the values of A, B and C in equation 1. By substituting the values in equation 1, we got F equal to K capacities, M raised to A equal to 1, V raised to B equal to 2, R raised to C equal to minus 1. So how much we got? K into M raised to 1, V raised to 2, R raised to minus 1. Or it can be written as F equal to K capacities mv square divided by R raised to minus 1 can be written as divided by R. F equal to K into mv square divided by R. So then what is K here? K is proportionality constant. This is dimensionless constant. So experimentally we are going to write the value of K as, see, experimentally the value of K is found to be, 1. What is the value of K? K equal to 1. Hence, the above relation becomes, the required relation is, what is the required relation now? F equal to, in place of K we can write 1 into mv square by R, or multiplied by 1 means we will get the final answer F equal to mv square divided by R. This is the required equation. Is it clear? Once again I will explain the problem. First step, we have to consider the equation in terms of A, B, C, equation 1. Second step, we have to write dimensional formula of equation 1. Third step, we have to find the value of A, B, C. Fourth step, substitute all the values of A, B, C in equation 1. Then at last, the K value is found to be 1 experimentally. Substitute 1 in place of K. So finally, the required relation we got F equal to mv square divided by R. So by solving more number of examples, you can understand how to derive the given equation clearly. Now I will solve one more problem. You can read the problem here. To derive the relation P equal to rho GH. We corrected this equation in the previous class. This is to derive the relation using dimensional analysis where P indicates pressure, H indicates height, rho indicates density, G indicates acceleration due to gravity, or the pressure exerted by the liquid depends on height of the liquid column, density of the liquid and acceleration due to gravity. Derive the required relation for pressure using the method of dimensional analysis. So here in your examination, either they may ask the question to derive the relation up to this, or they may ask the question the pressure exerted by the liquid depends on height, density, acceleration due to gravity, or they may ask the question derive the required relation for pressure using the method of dimensional analysis. So these are the way of asking the question. So now we can solve the given equation rho GH. Now tell me what is the first step. So the given equation is what? Given equation is P equal to rho GH. So this equation first we have to write in terms of proportionality. P is directly proportional to. So here I can write rho raised to A, G raised to B, H raised to C. In this form, first we have to write the given equation. Or this equation can be written as P equal to proportionality constant K into rho raised to A, G raised to B, H raised to C. So this equation we can consider as equation number 1. Where, what is K? Where K is dimensionless constant. Dimensionless constant. Now, this is first step. What is the second step? Writing the dimensional formula of equation 1. So now we have to write the dimensional formula. Writing the dimensional formula of equation 1. Yes, pressure is given by the equation. What is the equation for pressure? Pressure is force per unit area. Force per unit area. That means I can write directly. Pressure is given by m raised to 1, L raised to minus 1, T raised to minus 2. This is dimensional formula for pressure is equal to. So K, this is a dimensional constant, leave it. Remaining is what? Rho G H. So rho is what? Density. Density is mass per unit volume. So I can write in place of rho as m raised to 1 divided by L raised to 3. This is rho value. Rho raised to A capacities. Then G indicates acceleration due to gravity. Acceleration is given by the equation L divided by T square. L by T square raised to B. Then H value. H means what here? Length. Height. Height is equal to length. So L raised to C. Right? Or it can be written as here m raised to 1, L raised to 1, T raised to minus 2 is equal to, I can write this equation as m raised to 1 into A. That will be m raised to A. Then L cube. This is L raised to, I can write here minus 3A. L cube is taken to numerator, it becomes L raised to minus 3 into A. L raised to minus 3A. Then here L raised to B. T raised to minus 2B. Then last term L raised to C. Or we can write as here m raised to 1, L raised to 1, T raised to minus 2 is equal to, here I can write m raised to A capacities, L raised to minus 3A plus B plus C. Bases are same, power must be added. So I can write here minus 3A plus B plus C. Remaining is T raised to minus 2B. This is the equation. Let us take it as equation number 2. Is it clear? Then what is the third step? Equating. Equating the dimensions of m, L and T on both sides of the equation. On both sides of equation 2. Yes, comparing these two values from LHS and RHS. So m raised to 1, m raised to A. That means A equal to how much? 1. Then L raised to 1. Here it is L raised to minus 3A plus B plus C. I can write minus 3A plus B plus C equal to 1. Then third point, T raised to minus 2 on LHS, T raised to minus 2B on RHS. So we can write minus 2B is equal to minus 2, or minus sign will get cancelled. 2B equal to 2. 2 will get cancelled. Therefore, B equal to 1. Is it clear? Now, we got A value and B value. How to find the value of C? Now I can solve That equation here, minus 3a plus b plus c equal to minus 1. Substitute the value of a and b here. Minus 3 into 1 plus c equal to minus 1. Minus 3 into 1 is minus 3. Minus 3 plus 1 is minus 2 plus c equal to minus 1. C equal to minus 1 plus 2. So we got 1. So therefore C equal to how much? 1. A equal to 1, B equal to 1, C equal to 1. Now I can substitute their value in equation number 1. What is the equation number 1? P equal to K into rho G H. Rho raised to A, G raised to B, H raised to C. So this is equation 1. So A equal to 1, B equal to 1 and C equal to 1 we got according to dimensional analysis. Substitute A, B and C values in equation number 1. We get P equal to K into rho raised to 1, G raised to 1, H raised to 1. That means P equal to K into rho G H. Therefore, experimentally it is found that, what is the value of K? It is found that the value of K is equal to 1. Therefore, P equal to 1 into rho G H or P equal to rho G H. So, this is the required equation. Is it clear? So, the required relation is P equal to rho G H. So, then come to the third example. To derive the relation A equal to V square by R using dimensional analysis, where A is centripetal acceleration, V is speed, R is radius of the circular path. The centripetal acceleration of a body in a uniform circular motion depend on its speed and radius of circular path. Derive the required relation for centripetal acceleration on the basis of dimensional analysis. So what is the given equation here? The given equation is A equal to V square divided by R. So this problem I am going to give you as an assignment. So try to solve yourself. You can follow the first two example. So I will give you some hints here. So we have to write this equation as A is proportional to V square by R. So or we can write the equation A is proportional to V raised to A, R raised to B. Or we can write A equal to proportionality constant K into V raised to A, R raised to B. So I had given equation 1. Remaining part, try to solve yourself to get the required relation. So remember the third example I had given as assignment. So solve yourself. I will solve the fourth example. To derive the relation V equal to root of G into R using dimensional analysis, where V is speed of the satellite, G is acceleration due to gravity, R is a radius of the earth, or the orbital speed of the satellite moving close to the earth depends on acceleration due to gravity and radius of the earth. Derive the required relation for orbital speed on the basis of dimensional analysis. See here, first we have to write the given equation. What is the given equation? V equal to root of G into R, where V indicates orbital velocity, G indicates acceleration due to gravity, R is radius of the earth. So this equation can be written as, see here, first we have to write this equation as V is proportional to G raised to A, R raised to B. Or we can write here V equal to proportionality constant K into G raised to A, R raised to B. Let us take it as equation number 1. This is first step. So where K is proportionality constant. Then the second step, we have to write the dimensional formula. Writing the dimensional formula. Writing the dimensional formula of equation 1. So what is the equation 1? V equal to K into G raised to A into R raised to B. So we have to write its dimensional formula. On LHS side, V is speed or velocity. Velocity is given by the equation L by T. Keep as it is. E is equal to K is dimensionless constant. Leave it. Come to the term G. G is acceleration due to gravity. Acceleration is given by L by T square raised to A into radius. Radius is equal to length. So length means L raised to B. Or we can write the equation as here. On LHS side, L by T. That means M raised to 0, L raised to 1, T raised to minus 1. On LHS side. On RHS side, we can write L raised to A, L raised to B, then T raised to minus 2A. Is it clear? L raised to A, L raised to B, T raised to minus 2A. This is on RHS side. Now, we can write this equation as M raised to 0, L raised to 1, T raised to minus 1. E is equal to, here the term M is not there. So, we can write M raised to 0, L raised to, here A, B. Bases are same, power must be added. I can write L raised to A plus B, T raised to minus 2A. This is equation number 2. Now, this is second step. What is the third step? Equating. Equating the dimensions. Equating the dimensions of L and T. Because M is 0 here, L and T on both sides. On both sides of equation 2. So compare these two values. M raised to 0, M raised to 0, leave it. So we have to compare only L and T. So I can write A plus B equal to 1. Here T raised to minus 1, T raised to minus 2A. Minus 2A equal to minus 1 or 2A equal to 1. A equal to 1 by 2. Right? Then here A plus B equal to 1. A equal to how much? 1 by 2 plus B equal to 1. So B equal to, we can write 1 minus 1 by 2. So here we can get the LCM as 2. 2 minus 1 will be 1. So again we got the answer B equal to 1 divided by 2. A equal to 1 by 2 and B equal to 1 by 2. These two values where we have to substitute? We have to substitute in equation number 1. So here I am going to substitute. What is the equation 1? Equation 1 is V equal to K into G raised to A, R raised to B. This is equation 1. So we got A equal to 1 by 2 as well as B equal to 1 by 2. Substitute the value of A and B. Substitute A and B in equation 1. We get V equal to K, keep as it is, G raised to 1 by 2 into R raised to 1 by 2. Or we can write V equal to K into G raised to 1 by 2 means what? Root of G into root of R or root of G into R. So we know that therefore K equal to 1 and the above equation becomes V equal to root of GR. So this is the required relation. Is it clear? So this is fourth example. Third example I had given as an assignment. One more problem I will give you as an assignment. Try to solve yourself. The problem is to derive the relation K equal to half mv square using dimensional analysis, where kinetic K indicates kinetic energy, M indicates mass, V indicates speed, or the kinetic energy of a body depends on its mass and speed. Derive the required relation for kinetic energy on the basis of dimensional analysis. So this is the given equation K equal to half mv square. Note down this problem, try to solve yourself. Third problem and fifth problem I had given as assignment. Try to solve yourself. You will get perfect in this deriving the relation. This is the second application. Remember these example I will explain in the next class. Thank you.